Hi friends, let me explain today about the features of latex where we can draw figures or circuits in the latex using Circuitikz. Suppose this is my figure I want to draw. This is my electrical circuit I need to draw. For this actually I need to write latex code, something like this one. This is some text studio where I have written the latex code for this figure. So here all this is like preamble required, initial things required. The main code lies somewhere here. Okay, so from this line, this is the code to draw the circuit. Okay, up to this part. So once we write this code, we get this figure. Okay, because we are interested in lattice drawing of the figures, as they won't lose any. Uh, we will get high quality pictures here by using this latex drawing. You can see it is very high quality. Okay, so let me say, but the problem here is we can always, it is difficult to write this much amount of code. Okay, so I actually thought to use some graphical interface to obtain this circuit. Okay, I have started, but fortunately I have found something like this code, Java code, from this person called Bellafire. Okay, so he has put the code in GitHub. Even you can watch it. Everything he has explained. Okay, and he has given the code also. So something like this one. Okay, so here suppose this is the origin where we need to we can take the elements from here, path, resistor, inductor, capacitor, everything here. Okay, suppose it is path, we can select from here and we can drag it here. Okay, so we will be getting here the shortcut commands here and then the lattice code for this one here. Okay, so okay, his person have done contributed good things here, but still there are some limitations here, like we can only draw from here to this node. Okay, the middle lines are missing here. So what I have done is I have taken the code and I have updated myself and modified this as like this. Okay, where I have added the grid here. Okay, and then I have created the actions for the save and open and code for full code. Here if you go for full code, the latest code will be generated here. Part code, only the part code, the main code as I have shown here, shown previously, that will be displayed. Create PDF, it will create the PDF. Okay, from it will convert the code to PDF and then it will show the PDF file. So why not, we shall start here. Okay, so one more thing I have done, what I have modified is I have actually these switches are there in most devices. Okay, this I have made rotation other than the person. I have created rotation here, orientation. So anyhow, if we want to delete this one, we can select here and we can press delete here. Okay, let me draw this circuit here, this one. So for which I need to take a battery here. So battery I'm taking. Okay, something like I can add here almost I'm going for 6 points here for the battery. Then battery, like okay, then let me go for path here, wire. Let me take 2 points here, and similarly here also 2 points. Then suppose I want capacitor, I can simply go for capacitor here, the middle point I can leave. Similarly capacitor here also. Okay, if you want we can change the notations code here. See, this is the latex code actually. I want the C1, I want to print here C1, so C underscore 1 I'm saying. I want it to be in at the left side, so I'm putting underscore here, I underscore. Similarly here I want this second capacitor to be C2 and it should be at the left side. Okay, like this we can change whenever we require. Then again I want a path here, suppose here, let me say up to here. So but this path should have some junction here, so what I'm doing, I'm adding a junction at the starting, it is here. Okay, then again another wire. So you can see this not joined here, so we can remove this if you want. See, okay, and we can create again. This is the only limitation. Still we are updating the, I am updating the code here. Okay, so this, as I said, it should be something like C2. Okay, then something like now I want again this wire, something at bottom up to here. Okay, then again say this wire to be having a junction, and I think this is not completely done. Let me go for again up to half what exactly I want. Okay, okay, then it should be having it. Now what, we need MOSFET switches, so let me go for this NMOS here. Okay, NMOS I want exactly at the center here. Okay, one is here and other is here. Okay, now I can join the, take the path and join them. One here, another here, and another here. Okay, now let us name this. Let me remove this number here. I don't want any number. Okay, and I want it should be, the switch name should be say Q1. Starting switch should be Q1, and then second one it should be say Q2. Want to keep in dollar symbol to have that mathematical operation. Okay, then that is Q1, Q2. Now let us go for this in inductor and capacitor here. So before that, let me put small wire here, path. Okay, from here to like up to here. Let me put some wire, or let's take from up to here. Okay, then I want something like, it's a joint, so we want a junction here, junction. Then again I want inductor junction, and then let me say I need to have the current ILR here. So I will say I equal to ILR I underscore in the dollar symbol, dollars notations, I underscore LR. Okay. But I want this to be at the bottom, so I'm putting underscore I underscore. Okay. Now let me go for the inductor here. Inductor, say to 2 parts to 2 lengths. Then again capacitor 2 points. Sorry, it's inductor only. Let me go for capacitor here. Okay. Now this should be LR and this should be my CR. Okay. And then let me first of all let me draw the diodes there this side. Okay. So let me take the diode from here to top to here. Okay. This is diode and we should have some junction at the bottom. So I'm putting star hyphen, then name should be D1. Okay. Then again let me go for the path here. Let me go for another path, something somewhere here. I need to have a junction somewhere here. Okay, so what I will do, I will use jump notation. This I have created, being taken from again some external source. Okay, here I want jump, so what the jump is. Now I will put a wire here. Let me go from here to there. Okay, that's wire, and it should have some junction there. So what I'm saying, junction. Again, wire from here to say here. Okay, of course we should have a junction, so let me remove that. Okay, let me draw the path here. Okay, then let me have a junction here, jump here, 2 points I'm taking for the jump. Okay, let me have the path here. Okay, then again the path and the diode here. Okay, that's the diode. So again this diode is D2. Similarly go for the other diode somewhere here. We shall go, this is one diode and its name is D3. Again another diode, to here. Okay, this is D4. Okay, so in this way I can draw the diodes, and then of course this D4 should have some junction at the bottom, so I'm putting that. Okay, similarly diode top will have a junction. Let me put that. Okay, then the path from somewhere, these two should be joined, and the bottom this wire should have a joint at the bottom. Okay, then again from here to here a wire. Okay, now again let me go for the path here, say up to here. Similarly here also a wire. Okay, capacitor, let me put a capacitor here. This capacitor, its name is C0, and it should be at the left side. The name should be at the left side. Something underscore here. Of course, it should have both junctions here. So what I'm saying, top and bottom junctions. Then again, path, something like here for the load. Similarly, from here to here a load. Then last resistor will be having a load resistor. Okay, for which again we can name it as R, but it should be at the left side, and then we want also the voltage notation, so we will be saying V equal to V naught. Okay. That's all mostly. Again, suppose I want labels A, B, C, D, so let me say my label here it is A. Okay, and its name should be A. That's what I'm writing A. I want it should be exactly at that point, so I'm not putting any directions for left or right. Then again another label somewhere here, and it should be something like B. Okay, again exactly the same point. Then again, sorry, actually it should be something, these two should be left actually, so let me go for left here. This also should be on the left side of the notation. Okay, then again another label somewhere here, and it should be something like C, and again it should be right, no problem. Then again another label somewhere here, we can use the new name for it, or else we can keep it B again. Let me go for new name, something like D. Okay, right, no problem. That's all. Okay, so mostly we have done. And suppose that we are adding a voltage notation for this battery also, so let me say my V equal to V underscore DC. Okay, then what happens now? Let us see the whole profile. Like I'm going for we can save this one, something like, let me save this as this code, what I'm saying in Java code. So let me save this one as sample, and the file name should be .src relation file. Okay, then we're saving it. It's done. Then let me go for full code. I want the full code, and you can see here this is the folder where we are not having any test sample file. Here I am creating now code, full code, what I am saying, test sample. Okay, dot tx file, save. It's created actually, but we can see here test sample. Okay, this we can open directly in the latex here. Okay, where you can see this is the total code. You can see this is the code we have got now. It generated with the code. Okay, you can see the file name test sample. Now you can run it directly from here. Okay, this is the code we have got. Only mixing is something like this one. This is mixing here, v0. Okay, so what can we do is we can minimize this one. Okay, this is the actual figure, and this is the code. Okay, you can see here. You can reduce this one. Okay, you can see here this is mixing. So what we can do, we can simply select this R here, and what we want is the v0 should be the right side. So I'm putting at the arrow. Okay, now we can save it actually. Code, and we can save this sample. Okay, save. Once we save it, and here you can directly run it. Okay, you can check it here itself. It is running actually now. So you can see v0. This is fine now. But here you can see the battery is having plus and minus little abnormal. Okay, that we can adjust something like I don't want the polarities of the battery here. But what I will do is I will keep an open wire which we have in the polarities. Okay, so I'm taking a open wire, something like I'm taking a path here. Okay, then I'm adding this one somewhere here. Okay, somewhere here, little distance, and we can say it as open. Open means wire will not be visible, it will not be shown, drawn. Okay, and we want my v equal to as vdc, v equal to vdc. Okay, and it should be at the left side only, so no problem, we can keep underscore. Right, then it will go for full code, same test sample. Now let us run it. It is a little odd. Okay, what the problem is here? If we need to add some brackets here, that's one problem. Then again, not this much far, so what shall we do is little reduce that far, that distance. Okay, something keep here itself. Okay, and this is okay. Now let me say full code, and again let me run it. If yeah, let me run it. Okay, still we can reduce, put it a little near. Okay, this is what the file we are getting. Okay, I can zoom it if required. See how clarity it is. We have done the figure in the using Circuitikz in latex. Okay, using graphical interface that is done through Java. Okay, of course, if I click create PDF, it will itself create the PDF file without text studio software. And this is the file I want to run it and open. Okay, so it will first of all convert into latex. Okay, then it will open. This is what this sample it's one opened here. Okay, you can see here. This is what figure we have got. So in that way, we can have this tool is useful. This Java interface is useful for graphical interface of the drawing circuit diagrams using latex. This will generate latex code that we can run in the latex to generate the circuit file. Okay, that's all. Still this we need to I need to update this these things somewhat user friendly. I need to do that. I will do, and I will try to uh, make available this software or this code in online. Okay, so thank you.